Welcome back to Inspire tutorial. This is Yasin and we are discussing about metals and non-metals. We already discussed how to distinguish metals and non-metals based on their physical properties. Now we are going to see how do we distinguish based on their chemical properties. So first one is reaction with oxygen. So both metals and non-metals, they can react with oxygen to give their oxides. But how can we distinguish those metals and non-metals? See, for example, iron is a metal and it rusts in presence of oxygen and moisture. We all know that. So here iron reacts with oxygen in presence of moist air to give rust. That is nothing but iron oxide, or we call it as ferric oxide. The rust is a reddish brown substance which is nothing but ferric oxide. Rust is ferric oxide. And similarly, copper also reacts with oxygen when it is exposed to air. You must have seen a green color layer on a copper vessel. So what is the reason for that? The copper is also a metal which can react with oxygen, which will form copper carbonate and copper hydroxide. So the green color layer on the copper vessel is nothing but it is a mixture of copper carbonate and copper hydroxide. And then how do we distinguish between metal and non-metal? So for example, if you take magnesium, burn magnesium in presence of oxygen. So when you burn magnesium in presence of oxygen, you will get a compound which is called magnesium oxide, and dissolve this magnesium oxide in water. So when you dissolve magnesium oxide in water, you will get a mixture, a new substance, and you are going to test that substance with the red litmus. When you put a red litmus paper into that mixture, the red litmus changes to blue color. So what does it indicate? The substance which is obtained by dissolving magnesium oxide in water, that will be basic in nature. So that's why the red litmus changes to blue color. Now what is that substance which changes the red litmus to blue litmus in this case? That is nothing but magnesium hydroxide. When magnesium oxide dissolves in water, you will get magnesium hydroxide, which is a base. That means metals will form basic substances, or they will form bases. Now come to non-metals like sulfur. When you burn sulfur in presence of oxygen, you will get sulfur dioxide. Now dissolve this sulfur dioxide in water. So when you dissolve sulfur dioxide in water, you will get a substance which is nothing but H2SO3, which is called sulfurous acid. Now test this sulfurous acid with a litmus paper. When you test this substance with litmus paper, the blue litmus changes to red color. Obviously it happens because this is an acid. So from this we can say non-metals can form acidic substances or acids. So depending on the nature of the substances which are formed by the combustion of metal or non-metal, we can classify them as metals and non-metals. So this is how we can classify metals and non-metals based on their chemical properties. First one is with reaction of oxygen. So the next one is the reaction of metals and non-metals with water. So when you take metals, they react with water and they form hydrogen gas, whereas non-metals do not react with water. So how can we see this? So you take a metal like sodium and add this sodium to water. So you should be very careful while taking sodium. So you can take a small piece of sodium because the reaction between sodium and water is highly reactive and vigorous. So when you react sodium with water, you will get sodium hydroxide and hydrogen gas. So how do you test whether hydrogen is released or not? So here what we do is, you take a test tube which contains a small amount of water like 5 ml, and then add a very small amount of sodium, a small piece of sodium. Instead of test tube, you can take a beaker also. It's better to take beaker only. So if you add this sodium to this water, you can see a gas released. You can see a gas, colorless gas released. So now when you keep a burning splinter over here or burning matchstick here, when you place a burning matchstick here, what do you observe? So the gas which is released, that will put off the flame with a pop sound. So you will hear a pop sound over here. That pop sound confirms the release of hydrogen gas in this case, right? But whereas when you take non-metals, they do not react with water. Hence, generally the highly reactive non-metals like phosphorus, it can easily react with air and burns. So to prevent oxidation of phosphorus, it will be stored in water. Phosphorus can be stored in water. This is an important bit. Phosphorus is a non-metal which can be stored in water because it is highly reactive with air but does not react with water. Whereas in case of sodium, sodium is highly reactive, like potassium also is very highly reactive, and these metals cannot be stored in water, nor they can be exposed to the air. So that's why sodium and potassium, they can be stored in kerosene, because the metals can react with both air and water, so they are stored in kerosene. Whereas non-metals can react with air but they do not react with water. Hence the non-metals like phosphorus, it is stored in water. Let us see how to distinguish metals and non-metals using dilute acid. So here metals, they can react with dilute acid, but non-metals cannot react with dilute acid. So you can test like this. So you take a magnesium wire, or you can take a piece of magnesium ribbon and put this magnesium ribbon or a piece of magnesium in a test tube, and then add a dilute acid. It can be dilute hydrochloric acid or dilute sulfuric acid. Then you will see a colorless gas released. So what is this colorless gas here? So again we'll test with the burning matchstick. So when you put the burning matchstick near the open mouth of the test tube, you can see or you can hear a pop sound. You can hear a pop sound which confirms again here a gas which is released is hydrogen. So when a metal reacts with a dilute acid, it gives hydrogen gas. Whereas if you take sulfur and add HCl to this sulfur, there will be no reaction. If you repeat the same thing with sulfur or any other non-metal, you won't hear any pop sound or there will be no observation like this. So with this we can say metals can react with dilute acids to give hydrogen gas, whereas non-metals do not react with dilute acids and they do not give hydrogen gas. So let us see how to distinguish between metals and non-metals using bases. So again here the non-metals cannot react with bases, but metals can react with bases, and not all the metals, only the metals like aluminium, zinc and lead. So when you add aluminium metal to sodium hydroxide solution in a beaker, you are taking sodium hydroxide solution in a beaker and adding aluminium, again you see a colorless gas released. So again what you do, you will put a burning stick over here and you will hear a pop sound. So again which confirms the release of hydrogen gas when aluminium reacts with a base like sodium hydroxide, or you can take potassium hydroxide also. That means the metals like aluminium, zinc and lead, they will react with bases which gives hydrogen gas. This is how we discuss or we distinguish metals from non-metals based on the chemical properties. That is reacting with oxygen, water, dilute acids and bases. Now let us discuss what is displacement reaction. So when you take these reactions, copper sulfate, which is a blue color solution, when zinc is added, that will give zinc sulfate and copper. So in this reaction, what happens? The copper in the copper sulfate will be replaced by zinc. So here zinc replaces copper to give zinc sulfate. Similarly, when copper sulfate is treated with iron, the iron can also replace copper, giving ferrous sulfate. And when you take zinc sulfate and copper is added, you cannot get copper sulfate. This reaction is not possible. The copper cannot displace zinc from the compound of zinc because zinc is more reactive than copper. Zinc can replace copper, but copper cannot replace zinc. So that is based on the reactivity of the metals. So the metal which is more reactive, that can replace a less reactive metal from its compound. So this is called displacement reaction. So displacement reaction is the reaction in which a more reactive metal can displace another less reactive metal from its compound. So that is called displacement reaction.